is like my second time or third, fourth, maybe fifth time trying to record this because I'm just like that. I get that distracted, so I just have to redo this until like it's somewhat perfect, I guess. I don't know. But yeah, I didn't do an introduction. I'm gonna do an outro. It's okay. Yeah, like I really want to be a YouTuber, so I gotta get this together or whatever. But we're doing a project on kinematic equations, and I am doing problem 10, second to last, on the ID acceleration motion problems. This is what the packet look like. Yeah, they have the answers on the back, so yeah, good looks. But the problem says a motorcyclist traveling 35.0 meters per second realizes suddenly that he is headed straight for the edge of the Grand Canyon, 50.0 meters away. He immediately begins to brake, decreasing his speed at a rate of 7.0 meters per second squared. With what velocity will he fly off into the canyon? A lot of information. We gotta break it down. Well, to me, like, because I'm slow. Well, I'm not slow, but it's like, I'm slow. So, first off, we're gonna draw a picture. I'm just gonna draw into this notebook because I ain't got no whiteboard and I don't got no chalk, and like I'm not gonna write on these walls because you know, like. So let's start off by drawing a picture. So in the problem it says he is headed straight for the edge of the Grand Canyon. So I'm just going to draw, like, I'm not like the best artist in the whole world, but like, you know, I'm somewhat okay with it or whatever. So right now I'm just drawing a picture of like basically what's happening in the problem. So he's traveling 35.0 meters per second, which is also his VO, if you guys didn't know. That's kind of rhyme. I really like that. And it says that he suddenly notices he is headed straight for the edge of the canyon, 50.0 meters away. Meaning he's right here. Oh, I should be showing you guys this. So this is what I got so far. This is his what is this called? I'm so sorry if y'all hear my mom in the background. This is his initial velocity. I'm gonna write that down. So VO. And then he is 50.0 meters away, which is his delta X. Alright, that's good enough. Y'all get it. So VO 35.0 meters, and then he's 50.0 meters away to the edge. You guys should get that because we're in high school and like we're not that slow, besides me. So this is how far he is, this is how far he's traveling, and this is how far he is from the edge. This is the edge. I'm not an artist, I'm not Picasso, so chill with me. Anyways, you get the visual. Basically, oh, I don't like how my room looking yellow right now. I don't like that. So after we drew the picture, we want to highlight what we have so far. So referring back to the problem, it says he's traveling 35.0 meters per second. That is his VO. VO is initial velocity, I believe. And then it says he's 50.0 meters away, which is his delta X, or distance, whatever you want to call it. It's stupid, I have two different names because I really hate that. But that's what it is. And then it says he's decreasing his speed at a rate of 7.00 meters per second squared, which is acceleration. But it says decreasing, so the acceleration would be like negative 7.00 meters per second squared. So yeah. And so the question is, what we're trying to figure out is basically like, with what velocity will he fly off into the canyon? Basically. So I'm 4 minutes into this video and I haven't did not one thing but draw that picture and like explain what the world is going on. So right now we want to go over our kinematic equations, and right now I'm just trying to figure out like which one works best. So let's go back to my notes. I should really have this ready. I'm so sorry, guys. I'm just really unorganized today. So in my notes, I have really sloppy notes because they're my notes. I have these 4 equations, and I want to find out which one will give me delta x. No, I don't. What am I saying? I want to find out which one gives me velocities, final velocity. That's what I want to figure out. So between these 4 equations, which one will give me the final velocity? And so I would pick the last one, v squared. What did it say? It say v squared equals VO2 plus 2a delta x. That's which one I'm gonna pick. So you should do the same. Okay. 5 minutes into the video, almost 6. Let me hurry this up because I ain't got time. Ooh, okay, but anyways, let's start getting into the math. The math's not going to take that long because you just plug and chug and calculate. And I finally got a calculator, period. Well, I've been had this calculator. I just lost it and then I found it. And so yeah, basically it. But let's get into it. So like I said before, our kinematic equation, we're going to choose v squared equals VO2, or squared, you know, plus 2 times a times delta x. This is the equation, you guys. I don't see it. You guys see it enough, so this is the one we're going to use. Because we want to find his, not the final velocity, but basically, but you want to find the velocity when he will fly off the canyon, which is final velocity, I guess. Y'all know what I'm talking about. So, this is kind of weird. I feel like I'm talking to myself, which I am, but like, you know. So, but what we know so far, we know we have VO, we know we have acceleration, and we have delta x. So, we just gonna plug in basically. So, it would be his, wow, I have to refer back into the problem. His VO is 35 point. I am just messing up right now. Maybe because I'm nervous. I'm not sure. Okay, so his VO is 35.0 meters per second squared plus 2 times acceleration, which is negative 7.00 meters squared, which is kind of weird. You know what? Don't put the meters squared. We just want to keep it as negative 7.00 parentheses times his delta x, which is 50.0 meters. Alright. My handwriting's kind of sloppy, so you guys just, like, you know, yeah. This is basically what I got. I'm trying to see if you guys can see it. I look stupid right now, but, like, yeah. So, yeah. So, basically, after you just plug and chug, it's just 35.0 squared plus 2 times negative 7.00 times 50.0. Come on. Okay. So, what I like to do first, I like to, like, you know, PEMDAS, PMDAS, you know, please excuse my dear Aunt Sally, because, like, why not? So, parentheses go first, so we're going to do 2 times negative 7.00 times 50.0. When you put all that into the calculator, you get negative 700. That's what you get. And then secondly, I would like to do exponents, so 35.0 times 35.0, or 35.0 squared, would be 1,225. Look at me, I'm a scholar. But anyway, so yeah. And you would add those together. Let me show you what I got when I did all that. So this, oh, you guys cannot see that. This is what I got. Found out the equation, plugged in, and did the math. And then you just gotta add those two together. And so when you add 1,225 plus negative 700, you get 525. That is not the answer. You still have to square root it. So when you square root 525, you equal 22.9128784748. But you want to keep sig fig, so you're just going to do 22.9. So, 22.9 will equals v, final velocity. So, you guys get that? I'm going to zoom in a little bit so you really can see my work and what I did. So, get the equation, plug in, do the math, square root, simplify. That's the answer, even though it's backwards, but still. So yeah, so the answer, he will fly off the cliff. Oh, units, I really hate that. He will fly off the cliff at 22.9 meters per second. That's when he'll fly off the cliff. And so yeah, that was my kinematic equations video, and I really hope you enjoyed it, and the nice scenery in the background. So yeah, and you guys want to see like the problem again, number 10, I also like underlined some things in there as a reminder, I guess. And then I showed my work and got the answer. Also, the answer's on the back. Let's see if I'm right. The answer on the back says 22.9 meters per second. And I didn't even look to see if I was right till just right now. So, yeah. And that concludes my video. And it's been like 11 minutes and 40 seconds. But I'm going to try and edit this video. I'm not sure yet. I look want to keep it going because I look like this. But yeah, bye guys. I forgot to say go follow my Instagram in the last video, but go follow my Instagram at it's for said. That's ITS the number 4 and SID, and my bracelet has my name on it. So yeah. Also go follow my Depot at it's for said and my Twitter at it's for Sydney1. I think that's my Twitter. It is. It's for Sydney1. So yeah, because it's for sale was taken up. But yeah, bye guys.